Hi class, how are you today? Really? Prove it. The learning target for today is to write a two-column proof to show that two triangles are congruent. So we did this with parallel lines, proving that those were parallel. Now we're going to prove that two triangles are congruent. So, a scale, 3, you can prove that two triangles are congruent. 2, you can prove that two triangles are congruent, but you have trouble with the reasons for each step. 1, you can determine if two triangles are congruent, but you can't prove it. So essentially what we did in the previous lesson. And 0, you cannot determine if two triangles are congruent. Let's get started. Alright, so just a quick reminder on what a proof looks like. It's a two-column proof. We have statements on one side and reasons on the other. So statements is where you say different things that help your case, like two things are congruent or parallel or something like that. And the reasons are saying why you know these things are true. Now, there's 3 parts to a two-column proof. The first part, the beginning, is where you write the things that were already given to you, your givens. And in those reasons, you will write given, because those are the things that were automatically given to you. The next is sort of the body of the proof. It's where you say other things that will get you to say why the triangles are congruent, to get you to the final part. So you start with the givens, and then you have the body. So this is all different things that will just help you get to the triangle being congruent itself. And then finally, this is the smallest part because it's one step, is the conclusion. This is where you will actually say that triangle, whatever it is, ABC is congruent to triangle DEF, or whatever it is. And this is the only part where you'll say the reason. And the reasons will be all the 3 letters that we talked about when we were talking about determining congruence. So an example one would be SAS. So you start by writing the things you were given, say that they were given, then add anything else you need to show that the triangle will be congruent, and say why you know that these things are true, and then state that the triangle actually is congruent, and why. Make sure you have the correct order when you write the triangle congruent statement as well, like we learned a few classes ago. Alright, next I'm going to talk about the reasons about why you can say triangles are congruent. So this section right here is going to be the reasons for your body of the two-column proof. So anything in the body part, you will probably use many of these reasons. Now, don't worry about writing all these down. You can if you want, but next class I will be giving you this paper anyway. So you don't have to worry about writing it down, but any additional notes I write, make sure you keep those down, or at least rewatch this video when you get this paper so you can write it on the spot. But I suggest writing what I add to this. So we'll quickly go through this. The reflexive property, it's just saying when something's congruent to itself. Yes, you do have to state if something is congruent to itself. It's a pretty easy one though. Like in this picture, we have 2 triangles, and we have to state that side AB is congruent to side BA. It's the same side, but it's part of both triangles. So you do have to say that they're congruent to each other, and the reason is reflexive property. Next, one we've talked about quite a bit, I think, is vertical angles. If you've got two lines that intersect, the angles that they make that are opposite of each other are congruent to each other. So, if you have a picture like that, you'll say that these two are congruent, and then you'll say that they're congruent because they're vertical angles. Next one, right angles are always 90 degrees, so they're always congruent. So if you have right angles in two different triangles, you know that they're congruent. So you say they're congruent, and you say, for your reason, right angles are congruent. The next, this one says alternate interior angles of parallel lines are congruent. This is one of the many parallel line pairs that we were just dealing with. And yes, alternate interior angles are one of them, but so are alternate exterior and corresponding. Those are also congruent, so you can also use those. Next, definition of a segment bisector. So if in the givens, they say that, like in this case, line T is a bisector of line segment TR, then that means TG is congruent to GR. And so you would say TG is congruent to GR, and the reason would be definition of a segment bisector. Next, we have definition of a midpoint, which is very similar to the definition of a segment bisector. It's just, it's a midpoint instead of a bisector. The midpoint does essentially bisect the two, but if it says that it's a midpoint, you have to say definition of a midpoint. If it says it's a bisector, you have to say definition of a bisector. Next, we have definition of an angle bisector. So, like in this case, if it says that, I can't really read these letters, look, it's like AD. So, if AD is a bisector of whatever this angle is, I can't read those letters, then you will know that this angle is congruent to this angle, and you would state that by writing the names. And the reason would be definition of an angle bisector. Definition of a perpendicular bisector, we probably won't really use at all because it sort of combines two. It combines segment bisector and it combines that right angles are congruent. So pretty much I suggest using right angles are congruent and segment bisector instead of just saying perpendicular bisector. And finally, third angle theorem. If you know that two of the angles are congruent, then you know that the third angle is automatically congruent, and that's known as the third angle theorem. Now, you may end up using ones that are not on this page at all, but most of the ones that you end up using will be somewhere on this page. And big part in geometry, and it just happened to be on here, and I like to say it all the time, do not assume anything if it is not in the given. So, just because something looks like it's a right angle, if it's not a right angle, you can't say it's a right angle, or anything like that. If a drawing looks like something's true, if it's not told to you, don't assume it. Alright, let's start with an actual proof. Alright, so let's start with this. So we have a triangle here, and actually, technically of 1, 2, 3 triangles. The two small triangles and the big one. Although they want you to prove that ABD, the first small one, is congruent to ACD, the second small one. So we want to prove that this triangle is congruent to this one. What we're given is that AD bisects BC and angle ADC is a right angle. So let's start our two-column proof. So we start by saying what is already given. So number 1, AD bisects BC. The reason is that it's given. Number 2, angle ADC is a right angle. And I'll just say is right to abbreviate, but is a right angle. And that is also given. So, now that we've set our givens, we're to the body of the proof. So our third thing is to pick something that will allow us to get to saying that the triangle is congruent. So the first thing that we are given is that AD bisects BC. So if AD bisects BC, that means BD and DC are congruent. And I'll even mark it right here. So those are congruent. So our next statement is that they're congruent. BD is congruent to DC. And the reason was because they were bisected. So you would say definition of bisector. The next statement we know that ADC is a right angle. That means that ADB is also a right angle, meaning that they're congruent. So you would say angle ADC is congruent to angle ADB, and the reason right angles are congruent. That's a quick shorthand to say angles. Right angles are congruent. Now, so we've got a set of sides congruent, we have a set of angles congruent, we need one more thing to be congruent. Well, notice that in these two triangles, they both share this side. So this side is congruent to itself. So statement 5 is that AD is congruent to DA. It's congruent to itself. And to say that something's congruent to itself, you would say reflexive. It's the reflexive property. So now that this one's congruent to itself, and I marked it with 2 dash marks just so it's different from these, we have a side, an angle, and a side in this triangle, and a side, an angle, and a side in that triangle. So now we can say those triangles are congruent by side, side, side. So that is our conclusion, our final statement. So 6, triangle ABD is congruent to triangle ACD. And the reason? Side, angle, side. And that's how you do a proof. Start with your givens, then the body, where you say the parts of the triangle that are congruent, and once you have enough in your triangle, you say the triangles are congruent, and you say why. Alright, got one more proof for you. Alright, so now for this problem, we have these 2 triangles here, and we're given that BC is congruent to CE, and angle B is congruent to angle E, and we want to prove that AC is congruent to CD. Now, this is a little different because for most of what you're doing, you're going to prove that the triangles are congruent. But for this case, you first have to prove that the triangle is congruent, and then use that to prove that these are congruent, and I'll get into why in a moment. So first, let's try to prove the triangle is congruent. So, start off by making your 2-column proof. Now, once again, start with your givens. Number 1, BC is congruent to CE. And that's given. And number 2, angle B is congruent to angle E, and that is given. And it's always helpful to make marks on your triangle so you can visually see what's going on. So BC congruent to CE, angle B congruent to angle E. Now, we have an angle and a side, an angle and a side. So all we need is one more thing, either a side or an angle. Notice here, these are vertical angles. They're created by these 2 lines intersecting. Vertical angles are congruent. So, you just say that these 2 angles are congruent. So, angle ACB, remember you have to say it with all 3 letters because angle C could be a bunch of different angles, is congruent to angle ECD. Just make sure that the C is in the middle for both. And we know that because they are vertical angles. So, we marked it on our triangle that those 2 are congruent. And we have angle, side, angle, and angle, side, angle. Just remember, quick thing, these have to have 2 marks, so we say that these 2 are congruent to each other, and these 2 are congruent to each other. If we had all 1 mark, we would say all 4 of these are all congruent to each other, which isn't necessarily true. So, now that we have angle, side, angle, and angle, side, angle, we can state that the triangles are congruent. Remember though, you have to put it in the correct order, and since they don't give you the order at first, you have to remember back from when we were doing congruent polygons. Notice if we start with ABC, so triangle ABC, we get triangle. So we said ABC, so no mark, 1 mark, 2 marks. Have to do the same thing. No mark, 1 mark, 2 marks. So DEC. DEC. And we know that because of angle, side, angle. So normally this would be your conclusion, that the triangles are congruent. So givens, body, and then conclusion. But we have even another part now where we have to prove that the sides are congruent. This is actually really easy though. It's just one extra step. You say AC is congruent to CD, and the reason is a nice little acronym called CPCTC. And what that stands for is corresponding parts of congruent triangles are congruent. So if you have parts of a triangle that correspond to the others and you already know that the triangles are congruent, you know that those parts are congruent. So you know that AC and CD, that those don't have marks yet, and they would correspond to each other because they both share these angles there. So these two are congruent. You can also say that about A and D. Those two correspond to each other as well, so those could be congruent. Although you don't need to state that because you only needed to prove this. But once you prove that triangles are congruent, you can prove that any of the corresponding parts are congruent to each other. Alright, so now time for the sponge. I want you to write a 2-column proof to show that the two triangles are congruent. And I give you that side AB is congruent to side AD, and AC bisects BAD. And I want you to prove that triangle ABC is congruent to triangle ADC. So write a 2-column proof, make sure you have all the statements and reasons. Alright, that's it for this lesson. Once again, please make sure to take notes on the entire lesson, take a picture of everything, submit it all to Google Classroom, and don't forget to put the rank. Have a good night.